Let's do a question in which we have to find the area of the triangle using the concept of congruence. Here is our problem. In triangle ABC below, D, E and F are the midpoints. So D is the midpoint of AC, F is the midpoint of BC and E is the midpoint of AB. DE is equal to half BC, EF is equal to half AC and DF is equal to half AB. We have to prove that area of triangle ABC is equal to 4 times the area of triangle ADE. For solving this question, the approach will be, we will prove that each of these small triangles is congruent to each other. Let's consider triangles ADE and DCF. That means this triangle and this triangle. In these two triangles, we have AD is equal to DC because D is midpoint of AC, this is given. Also, it is given in the question that DE is equal to half BC, so we can write DE is equal to half BC. This is given. And since F is the midpoint of CB given, that means CF is also equal to half of BC. So here we can write CF is equal to half BC. So this implies here that DE is equal to half BC and CF is equal to half BC. This implies DE is equal to CF. Similarly, we are given that DF is equal to half AB. So here we can write DF is equal to half AB. This is we are given. And also it is given that E is the midpoint of AB. So we can write AE is also equal to half AB. So we can write AE is equal to half AB. So this will imply, because DF is equal to half AB and AE is equal to half AB, so this implies DF is equal to AE. Now in triangles ADE and DCF, we have AD is equal to DC, DE is equal to CF and DF is equal to AE. That means all three corresponding sides are equal. Therefore, we can say here that triangle ADE is congruent to triangle DCF by SSS congruence rule. Similarly, as we have done here, we can prove that triangle ADE is congruent to triangle FED. That means this triangle is congruent to this triangle, once again by SSS congruence rule. Also, in the same manner, we can say that triangle ADE is congruent to triangle EFB. That means this triangle is congruent to triangle EFB, and this too by SSS congruence rule. What this means is that this triangle is also congruent to this triangle. So here we have triangle ADE is congruent to triangle DCF, triangle ADE is also congruent to triangle FED, and triangle ADE is also congruent to triangle EFB. That means all the triangles are congruent to each other. And when all the triangles are congruent to each other, their areas will also be equal. Since the triangles do not overlap each other, so we can write area triangle ABC is equal to area triangle DCF plus area triangle FED plus area triangle EFB plus area triangle ADE. This implies that area triangle ABC is equal to, we have already discussed that areas of all these triangles are equal, so we can write this as 4 times area triangle ADE. This is what we had to prove here. Let's summarize what we have done here. We have proved that triangle ADE is congruent to triangle DCF is congruent to triangle FED is congruent to triangle EFB by using SSS congruence rule. This implies area of these 4 triangles is equal. And that means area of triangle ABC is 4 times area of triangle ADE.